Hey Calculus, it's Mr. Florio. Today we're going to look at implicit differentiation day 2. If you have questions on implicit differentiation day 1 homework, up in the keys section in the content library, I posted the homework answer key to that homework, so you can check your work and see how I did it there. But for today, we're going to do some more implicit differentiation. We're going to build on what we started doing last class. We're going to find the derivative functions with variables other than x, so with respect to maybe with respect to y or with respect to something else. And then we're going to also work on finding the second derivative of these implicit functions. And this is just stuff that we're going to build on in the next section where we do some related rates problems. So that's where this is all going. So when we take the derivatives with respect to other variables, we have to apply the chain rule to the y term. So when we had something like, I want to take the derivative of y squared with respect to x, it was 2y times the derivative of y with respect to x, or y prime. So the idea is when the variables don't match, we apply the chain rule. So this x and that y, they were not the same variable. So then we had to apply the chain rule. And that's when we apply the chain rule, when the variables don't match. So let's look at some examples. So after you copy down this function, we're going to take the derivative with respect of this function, or not this function, this equation with respect to x, respect to y, and with respect to t, assuming both x and y are related to t. Okay, so taking the derivative with respect to x, this is like a review from the homework. We take the derivative of both sides with respect to x. So the derivative of y to the fourth is going to be 4y cubed, that's the power rule, times the derivative of y with respect to x, again, the chain rule. Now we have the derivative of negative 3y squared, it's going to be negative 6y, again, dy dx, because the variables don't match. Now the variable x's here do match, so the derivative of negative 2x squared is going to be negative 4x, and the derivative of x is just 1. The derivative of the constant 7 is 0. And then from here, we just factor out the terms from the dy dx. So if I take the dy dx out of the first two terms, I'm left with a 4y cubed and a minus 6y. And on the other side, we can add 4x to the other side and subtract the 1. So the derivative of y with respect to x, when we take the derivative with respect to x, it's going to be 4x minus 1. And then we divide the 4y cubed minus 6y on the other side. And that's it. But now what if I want to take the derivative of the function with respect to y? So what if I'm doing derivative of both sides with respect to y? Well, now the variables match, so the 4y, the y squared is just, the derivative is just going to be 4y cubed. The derivative of negative 3y squared is going to be negative 6y, and the derivative of negative 2x squared is going to be negative 4x. Dx dy now. The reason why is because the variables don't match. So the negative 2x squared is going to be negative 4x times the derivative of x with respect to y. The derivative of x with respect to y is just going to be dx dy, or 1 dx dy. You can put a 1 there if you want. And then the derivative of the constant is 0. And then we would do the same stuff. Factor the dx dy out of these last two pieces. So I'd have a negative 4x plus 1 dx dy. And then these two things I can bring to the other side. That's going to be a 6y minus 4y cubed. And that's our answer. So the derivative of x with respect to y is going to be 6y minus 4y cubed over negative 4x plus 1. You guys might notice that if we flip the dy dx, I get dx dy. And that will be true. So you can check if you did it right by looking at that, but make sure you go through the process. Because what we do on the bottom here is what we're going to do most of the time when we're taking the derivative. So this second example is for practice, just looking at it differently. This third example is going to be the one that we're going to see more next time. So now, what if I take the derivative of both sides with respect to t? Now none of the variables are going to match, so there's going to be there's going to be dy's and dx's because everything is with respect to time. So the derivative is going to be 4y cubed times the derivative of y with respect to time. We're going to get negative 6y times the derivative of y with respect to time. We're going to get negative 4x times the derivative of x with respect to time. And we're going to get the derivative of x with respect to time, or 1 dx dt. And the derivative of 7, again, a constant is 0. And the way we're going to handle these, because there's two variables involved, there's my dy's, and separately there's my dx's. So I'm going to bring all my I'm going to leave all my dy's on one side and all my dx's I'm going to put on the other side just to clean it up. So here, factor out the dy, I get 4y cubed minus 6y dy dt. Now on the other side, I'm going to add the 4x dy dt and subtract the dx dt. So let me just factor that out and we're done. So we got 4x minus 1 times the derivative of x with respect to t. And that's good enough there. I mean, you're not going to solve, there's two variables, so I'm just going to kind of, that's as neat as I want you to leave it. So leave it like that when we do it. Okay. So that's it. So let's look at this one. Let's take the derivative of this equation with respect to time and then solve for dx dt given x, y, and y prime. So same process. Let's take the derivative of both sides with respect to time. We got an implicit function. So the derivative of 6x squared with respect to time is going to be 12x dx dt. Negative 2x is going to be negative 2 dx dt. Y squared is going to be 2y dy dt. And the derivative of 3y is going to be 3 dy dt. The derivative of constant, of course, is 0. So at this point, you can plug in x, y, dy, dy. I'm going to solve for dx first and then plug in all my numbers at the end. So I'm going to factor out the dx from the first two. So I'm going to have 12x minus 2 times dx dt. I'm going to bring these two terms to the other side. So I'm going to have a negative 2y dy dt and a negative 3 dy dt. And I'm going to factor out the dy dt. So I'm going to have negative 2y minus 3 times dy dt. And to get dx dt by itself, we would just divide both sides by the 12x minus 2. And now I'll just plug everything in. So I'm asked to find dx dt, and it's going to be negative 2 times y minus 3 over 12 times 12 times x minus 2 times dy dt. So x is 2, y is 3, and dy dt is negative 1. So just plugging those numbers in. So let's see here. It's going to be negative 6 minus 9 is negative 12. 12 times 2 is 24. 24 minus 2 is 22. Times the negative 1, so the double negative is going to make that a positive, right? And that simplifies to, I don't know, what's that, 6 over 11? Okay. So if we're given all this information, we can actually find what dx dt is. And that's what's going to be happening once we start related rates. These equations aren't going to be random polynomials or look like polynomials. They're going to be stuff involving area, velocity, even volume, stuff like that. Okay. Now for taking the second derivative, so that's like the second half of this. Repeat the steps to take the first derivative like normal. When we take the derivative again, you're going to get a dy dx to show up. We're going to substitute what we got for step 1. Whatever the first derivative is, we're going to substitute that in for dy dx. And then there's going to be some sort of find and substitute again, and you'll see what I mean by find and substitute again. So these steps will make more sense after I do one. But find the second derivative of this equation, x squared plus y squared equals 16. That's a circle centered at 4. So with respect to x, so the derivative of both sides, I'm going to get 2x plus 2y times dy dx equals 0. So 2 dy dx equals negative 2x. If I had subtract 2x on both sides, divide both sides by the 2y, the 2's will divide out, and I get negative x divided by y. So when I want the second derivative of both sides with respect to x, right, we're going to have to use the quotient rule. Remember, low d high minus high d low over low low. So it's going to be the bottom function times the derivative of the top function. The derivative of negative x is negative 1, minus the top function, which is negative x, times the derivative of the bottom function. The derivative of y is dy dx, all over the bottom function squared. My g's and y's are starting to look like each other. Okay, so once we do that, the next step is to substitute dy dx in. So this is where I say our answer for part 1 we're going to substitute in. So we're going to take this piece right here, this is dy dx, and replace that dy dx with negative x over y. So y times negative 1 is negative y. This double negative is going to really be a plus x times dy dx, which is really just negative x over y, all over y squared. So I'm going to get negative y. A positive times a negative is going to be a negative. X times x is x squared over y times y squared. And right now I'm drawing my y's differently. I'm sorry about that. And so we did that substitution step. And now step 4, find and substitute again using the original function. The original function is x squared plus y squared equals 16. I'm going to try to find x squared plus y squared in this equation and replace it with 16. So I'm going to try to find that. And it's going to take a little bit of work. And this is what you can do here. I see the x squared. I'd like that to be positive. And I'd like to get rid of that y, and I'd like to turn that y into a y squared. So what I'm going to do here is multiply the top and bottom by negative y. Right? That's legal as long as I do it to the top and bottom. And then I just recognize that what that's going to do is when we distribute it, negative y times negative y is a positive y squared. Negative y times negative x squared over y, the double negative is going to make that a plus. Now when I multiply, the y's are actually going to eliminate each other, and I'm going to get my x squared. On the bottom, I have y squared times negative y, which is negative y cubed. And now I can replace x squared plus y squared with 16. So this is really just 16 over y cubed. Negative 16 over y cubed. And I'm just going to put the negative right here. And that's the second derivative. Okay, so it comes out nicely. This kind of second step where we find the x squared, y squared, and substitute it back in doesn't seem obvious, but you just kind of do some algebra to make it work. And the more problems you see, the more you'll kind of figure out tools. But all the stuff that you're going to do on your homeworks and stuff is going to be stuff that you've seen me do. Last question. Yeah, last question. Find the second derivative of x times y equals 18. So step 1, take the first derivative. When we do the first derivative, I have a product of x times y, so I'm going to need my product rule, fg prime plus f prime g. So it's going to be the first function times the derivative of the second. The derivative of y is dy dx, plus the derivative of the first function. The derivative of x is just 1 with respect to x, times the second function, which is y. And the derivative of 18 is 0. So we just took the derivative of both sides with respect to x. Let's solve for dy dx. So the derivative of y with respect to x. So bring the y to the other side. It's going to be negative y. Divide both sides by x. It's going to be negative y over x. The second derivative of y with respect to x, both times, we're going to have to do the quotient rule. So again, it's going to be the bottom function, right? Low d high minus high d low over low low. So it's going to be the bottom function times the derivative of the top. The derivative of negative y is negative dy dx. Minus the top function minus high d low. The derivative of the bottom function is 1. All over the bottom function squared. Okay. So now we're going to substitute. So the derivative, the first derivative, we're going to replace right there. So it's going to be, that's going to be a negative x. I'm just going to bring that negative x out times negative y over x. So here's my substitution. Here we have a double negative, so it's going to be plus y. Y times 1 is y. And over x squared. Again, I'm having some double negatives here, so those are just going to become positive. So we're going to get, let's see, anything else happen here? Oh, the x and the x is going to divide out. So I'm just going to get a y. So what am I left with? I'm left with y plus y over x squared, which is 2y over x squared. And now I need to do that second substitution step. Find and substitute using the original equation. So the first equation is x times y. I don't see an x times y, but what I could do is I can just multiply the top and bottom by x, and then I'll have it, right? So on the top, I'm going to have 2y times x is 2xy, and x squared times x is x cubed. So now I got that xy from the original equation to show up, so I'm going to replace that with 18. So I'm going to replace that with 18, and it's 2 times that over x cubed. So we're going to get 18 plus 18 is 36 over x cubed, and that's the second derivative. And it looks like it only depends on x, not x and y. So that's it. The whole taking the derivative of natural log of x. We'll get that. We won't do that I'll do that in class. I'm not going to do that just through a video, or at least I don't plan on doing that now. So if you have any questions, shoot me an email. If you saw a mistake that I made, please let me know. We'll get some more practice with this on Wednesday, and then we'll have that test on Friday. All right, have a good one. Bye.